So we're talking about de Moivre's theorem and powers and roots of complex numbers. Okay, so let's first talk about just how to motivate this. So let's say that I want to take this complex number and I want to square it. So in my previous video, we actually talked about a trick to do this. So this is going to be r squared and then this times itself. And rather than having to like FOIL it out, I can just use the product theorem. And this is what one of my previous videos was all about, so I'm not going to go through this again. But to apply the product theorem, I would take the 2-degree measures, theta and theta, and just add them together. And so I get r squared times cosine 2 theta plus I sine 2 theta. So, okay, this is, okay, whatever, right? But here's the thing. It turns out that this pattern, because there is a pattern, it continues. So what I mean is, let's say that I was now taking that same thing to the third power. Without doing all the work, you can believe me that this would be r cubed times cosine 3 theta plus I sine 3 theta. And so this cool party trick is known as de Moivre's theorem. So de Moivre, I do not speak French, so I am trying to say it as best I can. I've never learned French, so I'm really trying not to butcher it, but I've got a tough time a lot of times with French terms. Okay, so here's de Moivre's theorem. Like you can hear, I know like other languages, right? Because I try to like roll my R, which I know I'm not supposed to do. Okay, so anyways, so let's say I've got this complex number, and then I have some real number n. So the theorem says if I take this to the nth power, taking a complex number to the nth power will just give me r to the nth cosine n theta plus I sine n theta, or r to the n cis n theta. Okay, so this is pretty cool because look at this first example. So let's say that I want to take the square root of 3 plus I times the square root of 5 to the 8th power. Okay, so this would kind of suck to do, right? So first we want to convert this to its trigonometric form. The big hint on this is that we're taking this to the 8th power. This would take you forever because you'd have to multiply this together 1, 2, 3, 4, 5, 6, 7, 8 times. It would just take you a very long time. So it makes no sense to actually take this to the 8th power. So we're going to write this in its trigonometric form. And I'm just very quickly, I'm assuming that you're pretty good at this point. So I kind of whipped through that a little fast. Here's my work to find r. Here's my work to find theta. So you can just trust me then. So the trigonometric form of this is 2 square root of 2 cosine of 52 degrees plus I sine 52 degrees. Okay, so there's my trigonometric form, and now I want to take this to the 8th power. Okay, and so this is where this is kind of cool. So I take 2 to the 8th, and then I converted the square root of 2 to 2 to the 1/2 to the 8th just to help me figure out what happens with the powers. And then all I have to do is multiply the degrees by 8. Boom, there you go. Okay, and so 2 to the 8th is 256. And then this 2 to the 1/2, so I take 1/2 times 8, so I just need to find 2 to the 4th. And then I've also got, so 8 times 52 is 416 degrees. So we want to be between 0 and 360 degrees. So what I'm going to do is I'm going to subtract 360 from 416. So in the end, this becomes 4,096. And then if I subtract off 360, this is 56 degrees. So here's my final answer. And you could, of course, write it in the shortened form as well. So really saves us a lot of time. And we can extend this theorem to find nth roots of complex numbers. So just to be clear, what do I mean by an nth root? So the nth root, if I have some number x plus yi, the nth root of it is going to be the number where if I take that number to the nth power, I get back to that x plus yi. Okay, so this is a little tricky, but I'm just going to tell you what the nth root theorem says. And there's a couple of pieces to this. So we let n be some positive number, r is a positive real number, and then theta is something in degrees. Actually, it doesn't have to be in degrees. It could also be in radians. So if I have a complex number, then that complex number will have n distinct nth roots. So you can choose whatever you want for your n. This is kind of the crazy part. And then the nth distinct roots are found with this formula. nth root of r times cosine alpha plus I sine alpha. What is alpha? Okay, so alpha has its own little formula, and it can be actually in degrees or in radians. So if you have it in degrees, if your theta is in degrees, then you find your solutions using this formula. Theta plus 360 degrees times k over n. And you will find one solution from 0 to n minus 1. This probably sounds really confusing. I'm going to show you how this works in a second. So I would suggest just writing this down, and then I'll show you an example and we'll make more sense of it. Now, if your theta is in radians, then you just replace the 360 with the 2 pi. Okay, so let's find the 3 cube roots of -8. And you might be saying, I didn't know that -8 had 3 cube roots. So this is pretty cool. I mean, you could find as many cube roots of -8 as you want, actually. So I just kind of arbitrarily threw out 3. So -8, we have to put -8 into its trigonometric form. And I would recommend that you pause the video and do that before we go any farther. So you do that and hit play. Okay, so here's all my work to put everything in trigonometric form. So again, I'm assuming that you know how to do this because I've covered this in other videos. So I'm just going to note that here, and you saw my work a second ago. So the thing to notice with this is when I was working with this, my r was equal to 8, and my theta, I guess I didn't specify degrees or radians. I went with radians. Okay, so first you need those 2 pieces of information. The next thing that you do, so we said that we wanted to find 3 cube roots, so I take the 3rd root of 8 and I calculate what that is. And the 3rd root of 8 is equal to 2, okay? So hold that thought. And then I want to find alpha. And this is the part that I know sounds confusing. So I'm going to use the radian version of this formula. So notice when I originally told you this, I gave you this formula, and we had this n. So n is the number of roots you are trying to find. So notice that I have replaced n with 3 here, okay? And this is just the structure, so I've left the k here. So this is just the structure of how I'm going to actually go through and find my roots. So I'm going to show you the 3 roots, and then we'll talk about how to cycle through them. So these are the 3 roots. And so what I've done is I've taken this format and I've started at k equals 0 and I plugged in k equals 0. So if I plug in k equals 0, the 2 pi falls out. So I'm just left with pi over 3. Okay, next I go to k equals 1. So if I plug k equals 1 into this, I get pi plus 2 pi. That gives me 3 pi over 3. Okay, and then I go to k equals 2. And if I do that, so then this becomes pi plus 4 pi over 3. That will be 5 pi over 3. So you go from 0 until 1 below whatever number you have here. That is always how you set this up. So here is the structure of my roots, and then I can simplify them as you see here. Okay? So pi over 3, pi, 5 pi over 3. And so the 2 things I need now to talk about what my cube roots are, I needed this cube root of 8, which was 2, and then I needed these 3 different alpha measures. So let me just note those. And now, basically, I just fill these in for my roots. So I've got this nth root of 8. This is going to be what I put in the place of r. And then notice I cycle through each different alpha. So this is cosine pi over 3 plus I sine pi over 3. And then this is cosine pi plus I sine pi. And then, whoops, sorry, I just noticed a mistake. I wrote 7 instead of 5. And then, oh, I still got 1. Okay, there we go. And then I plug in this 5 pi over 3 into that. And so that is the structure of my 3 roots. And then if I wanted to put these into, say, their rectangular form, then I just go through now and I evaluate the value of these, of these, right? So I can just multiply everything together, and those would be my 3 answers then, or that would be my answer in rectangular form. So that's the idea. So I know the alpha looked a little confusing at first, but it's got a pretty predictable structure. And places where you can apply this would be also for like finding solutions to equations. So let's say I want to find all solutions to x to the 4th plus 1. Okay, so what you're going to do for this is you want to actually isolate x to one side and the number to the other. And so I've got x to the fourth equals -1. And so I want to take the fourth root of -1. And for a very long time, you probably thought that there was no fourth root of -1. That was just like not a thing. But actually, it is a thing. It's just kind of complicated. It's actually really complicated. So what we're going to do is I can totally find the 4 roots, because that's what I want to do. I want to take the fourth root of both sides. I can find the 4 roots of -1. And by the way, I know there's going to be 4 solutions because this is a 4. If this was a 7, I'd have to find 7 solutions. If this was an 86, I'd have to find 86 solutions. So whatever your power is, that's what's telling you how many solutions you need to have. Okay, so what I want to do is I want to write this -1 in polar or trigonometric form. So I'll just show you the work for that. And so here is my trigonometric form. You can check my work if you want. And so I'll just note that there's my trigonometric form. Okay, so let's go through how do you do this one more time. First, you take the cube root of this, and then you do the alpha formula to this. Now, I think that this is a little tricky the first time you get it. I would highly recommend that you pause the video here. Just try it. Even if you get stuck, that's totally fine. But try like to reference what we did before. Really try to see if you can get this on your own, and then this will totally click, I promise. Okay, so I take the fourth root of 1, which is just 1. Okay, cool. And then here's the structure of my alpha. So if you haven't tried to figure this out, one more suggestion to try this on your own. You've got the structure now. Try to figure out what alpha is, your 4 different alphas, and hit play when you're ready. Okay, so I'm going to cycle through k equals 0, k equals 1, k equals 2, and in this case now k equals 3. So we go to k equals 3 because I have a 4 on the bottom here, and I'm looking for 4 solutions. Okay, so hopefully this is starting to make more sense. And so now, here are my alphas. Here was my fourth root of 1. So from here, I can just plug this information in, and here are the 4 solutions. And I wrote the abbreviated form of cosine plus I sine. So hopefully you're familiar with this by now. And so, yeah, so then that's it. So nice and short and sweet video, guys. Hopefully that made sense. If you got any questions, you can always leave me a comment. And I will see you guys in the next video, which is our final video if you are in my trig class.